Who are we? For ages, we have been looking up at the sky, contemplating the enigma of our existence. Millions of species inhabit our planet. Together with them, we travel through space. The universe that we discover today did not always exist. A long, long time ago, there were no planets, stars, or galaxies in the cosmos. How did matter organize itself to produce life? How did our consciousness emerge among the stars? For centuries, we have been pondering nature. Today, thanks to the research efforts of generations of scientists, after centuries of measuring, calculating, and experimenting, we have uncovered one of its greatest mysteries. From atoms to galaxies, from cells to ecosystems, the secret of diversity is emergence. It is through this phenomenon that the simplest elements can bring into being the most complex forms, and why the whole is more than the sum of its parts. Emergence is at work in nature as it is in writing. Many written languages are founded on a limited number of basic elements, letters. Then, through their endless combinations, countless possibilities emerge. Combined in a specific order, letters form words. Combined in a specific order, words form sentences. In turn, sentences form paragraphs. Paragraphs form chapters, and chapters form books. Each level emerges from the previous while being different. New properties appear. Richness and complexity increase. The recipe is incredibly fertile. An alphabet of a few letters can compose entire libraries. All the information that they contain is the result of the association and arrangement of these letters. It is in the form that information resides. The same goes in nature. Matter organizes itself through the combination of a small number of basic elements, elementary particles. All the landscapes of the universe emerge from their infinite combinations. Elementary particles organize themselves into progressive levels, becoming more and more complex: atoms, molecules, crystals. With each level, new forms and possibilities emerge. The diversity of shape we see on Earth is exceptional. Throughout the cosmos, complex structures are less common than simple shapes. Thus, a diamond is far rarer than an atom, but less remarkable than a butterfly. Life weaves so many shapes and bonds. It thrives on so many exchanges. With each moment, our body transforms energy, maintains our chemical balance, interacts with the world around it. Seeing my hand open is an amazing miracle. Each one of us is formed by the interaction of about 10,000 billion living cells. Far more than the number of stars in our galaxy. Every one of these cells is an entire universe. A fabulous architecture comprised of hundreds of billions of molecules. Our molecules themselves are made of smaller elements called atoms. Unbelievably tiny. Atoms are made of even finer components. Quarks, electrons. These are our elementary particles. Each one of us consists of about 100 billion of these particles. Every second, they vibrate and interact within us. They allow us to breathe, look, and think. At this scale, our body is as vast as the cosmos. The elementary particles we are composed of have been around since the beginning of time. But originally, they were all separate. How did they organize themselves into what we see today? This is the great story of cosmic evolution. 14 billion years ago, the Big Bang strikes. Everywhere at once, a blazing expansion of space occurs. The density of matter and energy is unimaginable. The temperature is so high that matter is completely dissolved in a uniform soup. There are no structures. This is ground zero for the organization of matter. As the universe expands, it cools down. When its temperature drops under the 10,000 billion degree mark, the nuclear force smashes quarks together to form atomic nuclei. Matter reaches its first level of organization. Just as the temperature plummets to less than 3,000 degrees, a new association occurs. This time, electromagnetic force enters the picture, combining atomic nuclei with electrons. It creates the first atoms, hydrogen and helium, the simplest of all chemical elements. Fundamental physical forces are what drive cosmic evolution. They cause particles to attract or repel each other, constantly interacting. On the infinitely small and infinitely large scale, the universe takes shape. From there, another force will transform the face of the cosmos: gravity. This is what shapes the primordial matter into filaments and galactic masses. Under its dominion, galaxies interact for millions of years. Within galaxies, again under the influence of gravity, giant gas clouds coalesce, condense, and give birth to stars. Stars often spring into being as clusters. Hundreds of them can be born in the same nebula. Stars play a crucial role in cosmic evolution. They produce the diversity of the atoms of the universe. During the Big Bang, only the simplest of atoms were created. But within stellar cores at the heart of the stars, extreme temperatures and pressure allow the formation of more complex ones. Through nuclear fusion come carbon, nitrogen, and oxygen. These new atoms possess very special properties, some of which will prove essential to the chemistry of life. At the end of their existence, stars disperse the elements they have created into space. In a final explosion of unbelievable violence, the most massive stars produce even more complex atoms. Made up of dozens of elementary particles, they are sodium, potassium, calcium, and iron. Over generations of stars, galaxies grow richer from the diversity of chemical elements. Thanks to the stars, there are close to 100 different types of atoms in the universe. We are made of atoms that were forged by them. We really are made of stardust. In outer space, the next level of organization is reached. Atoms combine and new structures appear. Molecules. water molecules are formed in space, composed of 3 atoms, 2 hydrogen and 1 oxygen. Without the exceptional properties that emerge from this combination, life on our planet would not be possible. In the Great Orion Nebula, astronomers have observed more complex molecules made of dozens of atoms. At the time of our solar system's formation, the universe is a very different place compared to its initial uniform state. The cloud of gas and dust that contracts to give birth to our star and its planets is rich, containing the various atoms and molecules generated through cosmic evolution. From this abundance of chemical riches emerges the extraordinary diversity of landscapes in our solar system, the nitrogen plains of Pluto, the ice rings of Saturn, the frozen geysers of Enceladus, the methane lakes on Titan, the sulfurous volcanoes of Io, the vortexes of Jupiter, and the carbon dioxide ice caps of Mars. Everywhere in the universe, the interaction of forces prompts matter to organize itself, to create diverse worlds and celestial landscapes. But it is on our planet that this interplay of shapes and energy reaches its peak. Nowhere in the universe have we yet seen forms of matter as complex as the living beings on Earth. Did this complexity emerge elsewhere in the cosmos? Are there other beings among the stars? We still don't know. What allowed matter to reach new levels of complexity on Earth was the presence of liquid water. By fostering chemical exchanges, water allowed for the creation of giant molecules that were previously impossible to synthesize in space. The emergent properties of these molecules are astounding. They can filter substances, store energy, replicate themselves. They are proteins, sugars, lipids. At this stage, in the great story of self-organization of matter, a phenomenon as mysterious as it is exceptional occurs. Inanimate matter comes to life. The cell, the fundamental unit of life. Within the cell, an extraordinary world reveals itself, chemical reactions that store or release energy. Proteins with spectacular shapes comprised of thousands of atoms, infinitely long strands of DNA molecules, whose form encodes and perpetuates the recipe of life. Cells are born, and then they die. They sustain themselves, reproduce, and maintain their equilibrium. On a universal scale, each cell is a masterpiece of cosmic organization, a cathedral of particles beyond imagination. These are our ultimate ancestors. Another level of organization is reached when, in turn, single-celled organisms discover the recipe for association. By cooperating and specializing, they give birth to beings that surpass them. Multicellular organisms. Simple at first, these organisms grow in complexity over time. At the living level, another phenomenon merges with the physical forces to guide the evolution of matter and life. Natural selection. Survival and reproduction of the fittest allow life forms well adapted to their environment to persist. The complexity and diversity of living beings that have emerged on Earth is phenomenal. The flora and fauna that surround us are made up of hundreds of billions of cells. Creatures so complex that they themselves contain numerous levels of organization. Cells assemble into tissue, tissue into organs, organs into systems. Our body is a whole made up of innumerable parts. But in itself, it is also a part encompassed by larger groups, because the recipe for organization goes far beyond us. In turn, individuals of one species gather to form more complex structures. And families, packs, herds, and colonies appear. All of them societies. Much like at the cell scale, the specialization of individuals promotes the survival of the group. It leads to more efficient and better adapted communities. The next level of organization emerges from the interaction of species, ecosystems. Billions of microorganisms, plants, and animals establish relationships to form living wholes of extraordinary complexity. Maintaining balance between their elements, ecosystems form vast networks of interdependencies that are constantly evolving. The biosphere. It emerges from the interaction of ecosystems between themselves and with the global environment. It is the whole, formed by all living things on Earth. The biosphere is the most complex system known in the cosmos. Its existence is the result of 14 billion years of cosmic evolution. It is the only one we know. This thin, inhabitable layer on the surface of our planet gave birth to us. Who are we? Thanks to our billions of particles, any of us can close our eyes and say, I am. Our existence emerged from the cosmos, our cultures, our humanity itself. The world is an endless interplay of matter and light, a symphony of waves and particles, and we are a part of it. Through us, matter acquires consciousness, nature gazes at itself, and the cosmos contemplates its own adventure. We emerged from the stars. We are the universe.